Hello all, welcome to the webcast today. My name is Kelly Ricker. I work in developer relations here at GrapeCity for our mobile product Xuni. I'm joined by our program manager Chris Ripple, who's going to talk to us a little bit today about Android profiling tips. Chris, he specifically manages a couple of different teams here at GrapeCity, all related to our mobile products, and he has particular insight into Android development. So without further ado, I'm going to hand this over to Chris. Chris?
Thanks, Kelly. Yeah, like Kelly mentioned, today we're going to be talking about performance and profiling tips in regards to Android development. So to give you a quick overview before we begin, we're going to talk about performance and profiling tips. What are profiling tools and why do we use them? And the different tools available for Android development that come with the SDK, DDMS, and Android Studio. Then we're going to jump into a profiling sample. We're going to go through method profiling, investigating the heap space of our app, and then track some memory allocations using DDMS and Android Studio. And then to finalize, we found our pitfalls, our performance bottlenecks, but how do we fix them? We're going to touch base on some best practices in regards to Android Java development, layouts, and asynchronous programming. All right, so the case study. Here in GrapeCity on Team Xuni, we have 12 different developers in 6 countries, split between roughly 2 different time zones, Pittsburgh and Shanghai. So there's about a 12-hour difference. So when Shanghai is finishing up development, our Pittsburgh developers are coming into the office and they need to know what bugs have been fixed overnight and what tasks to work on. So we need to plan a new sprint every 12 hours. Here's the sprint planning app I wrote. It automatically pulls in bugs from TFS and puts them into a recycler view where you can easily scroll through and assign different bugs to different developers. So the requirements: I need to do 2 sprints a day. I need to plan the sprint within 30 minutes. From 6 a.m. to 6:30 is my window. And if I'm stuck in traffic or if I'm on the bus, I still need to plan the sprint so my developers can come in and start working immediately. So there's a couple bugs with this app. All right, the animation is pretty slow. The scrolling is pretty slow, and sometimes the app crashes. So performance and profiling tools. What is profiling? Analyzing the behavior in runtime. I'm looking at my code as it executes at runtime. Now I want to look at the measurement of time and space of my methods and the measurement of space my memory allocations are using. So why do we need it? Why can't I just look at my code, look at the big O and determine, how to improve my method, right? So that's a big no-no. That's called pre-optimization, and that's something you want to avoid, just doing guesswork. You need to collect data to compare your changes with. So if I fix my method, I need to know that it's 100 milliseconds faster, and the only way to do that is to measure the data using profiling tools. So the profiling tools available to us, we have DDMS, which has all these different features. And then Android Studio has been coming up with some new stuff in 2015 to kind of enhance what DDMS was missing. For today's talk, we're only going to focus on method profiling, heap view, and memory allocations in DDMS, and then the allocation tracker and the memory monitor in Android Studio. So we're going to start with doing some method profiling using DDMS. So there's 2 different types of method profiling, sample versus trace based. Now sample is going to collect data at different time intervals. So for instance, every 1,000 milliseconds, it's going to collect the stack trace and aggregate the data. Trace-based is everything, the entry and exit of every method call. So to do method profiling, it's pretty simple. You start recording, perform some actions on your app, and then stop recording to collect the data. All right, so let's open up our app. So here's the app I was mentioning. The scrolling's not too bad. Let's add some developers to the sprint. All right, so there's some noticeable lag now. All right, so this is the bug that we want to fix using method profiling. So I open up DDMS. Now this is available from Android Studio and Eclipse. And on this left-hand pane, you'll see your device that's connected to ADB. I want to come in here and find my application. Here we go. com.example.chris. So I have my application selected, and I want to start a new method profiling session. So I click on this button up here, this Start Method Profiling, and it gives me the options between sample and trace-based. So I'm going to collect trace-based. I want as much data as possible to analyze. Right? You'll click OK, and now it has Start Recording. So while it's recording, this is where you perform your actions. And whatever you perform on your app, that's the method calls that are going to be collected and measured. So I do some scrolling. I go back to DDMS, and I click that same button again to stop recording. All right, so for the purpose of this webinar, I had some pre-allocated data. So here's what we're looking at, right? It's kind of confusing. This top view is called the timeline panel. All right, so this is from in the last 500 milliseconds. This is what this time bar is measuring. This is the method calls that were executed in that 500 milliseconds from my scrolling. So these color-coded blocks, those are the large chunks of method calls, the same method call that's taking the most time. So I can come in and I can zoom in, and I can really dig deep and find what methods are, taking the longest. But this really doesn't help me too much. I need to look at this other panel, this tree view panel. This gives me a list of every method call and how much, in order of how much time was spent in that method. So what I want to do is I want to scroll down till I find my apps package. This is all Android native stuff, some animation, recycler view stuff. So I scroll and scroll and scroll until I find my package name, com.example.chris. So here is the worst performance-wise method in my app, the select developer list adapter. So I can come in here and look at the other methods being called inside this method under this tree, this child tree. So this gives me a list of every other method called in there and how much time it, relative to its siblings, it takes to execute. So I found my method. So let's go look at the code, right, and see if I can fix this. So I go back to Android Studio. So I'm digging through my code, and I find here that I'm loading a bitmap from disk every time one of my developers' thumbnails is shown. So this is a bug I want to fix, right? I want to maintain a cache of this bitmap, and I don't want to load it on the main UI thread. So later on in the presentation, I'll touch base on caching and asynchronous programming on Android. But for right now, I'm just going to go ahead and fix the bug. All right, so I'm going to redeploy my app, and then I'm going to check out the scrolling again, see if the bug has been fixed and the scrolling is now smooth. Now it's important when testing, when doing method profiling, to do the same actions every time you profile, so you have a similar data set to compare against. All right, so I'm scrolling and scrolling. It's much better, but there's still a little bit noticeable lag. Right, my app can still be improved. So I'm going to method profile again, find the next bug, start a new session, trace-based, click OK. All right, it's now recording. I go back into my app and perform some actions, collect some data. I do some scrolling, go back to DDMS, and then click stop. All right, so again, I got a new data set to look in. Scrolling down through this tree view, looking for my app's package name. All right, so I found another bug. It's not as bad as the first, but still something I can improve. Let's go back to Android Studio. All right, so I'm looking at my code and I see that I'm inflating this view every time instead of recycling it. Now, recycling is very important. I'll touch base on that later when I talk about best practices. So I go in, I fix the bug, and let's deploy my app again. Let's see if the scrolling has improved now. So I add a couple developers to my sprint. And all right, so the scrolling, there's no visible lag anymore. So this is pretty nice. So one other bug besides scrolling was the animation. So when I click on one of these bugs, it expands the description. And it might not appear to be lagging right now, but it's important to always optimize your app. You're not going to know what device your users are going to be using. Right now I'm using Android 5 on an emulator, but they could be using Android 2.3 on a 5-year-old device. So it's important to really optimize my app. So, we looked at method profiling, I fixed some bugs, but what other ways can I use to improve performance? Memory tracking. So in DDMS, it gives me what we call it's the heap view. It's the overall RAM that my app is taking. So I'm going to go ahead, we can look at the heap space, the total space allocated, how much space is free, the total number of objects, and there's even a graph for object allocation per size. But beyond that, I need like a full list of all my data and where each object is allocated. So that's where we're going to use the allocation tracker in DDMS. It gives me a list of everything. I can order by size. I can look at the full stack trace and what thread it's allocated in. So I open up DDMS, and on this right pane, I see some other options here. So heap. This is the heap view we want to look at. So I select my application, and I click this button up here, this Update Heap button, to enable the ability to look at my heap. Now you need to click on this Cause Garbage Collection button here to collect your data. Okay, so in this top table, I can see the total heap space my app is allocated. 17 megs. And my app is only using 13 of that. So 17 megs, that's not so bad. This view is really useful if your app is using 100 megs. Where if you're using too much RAM, the Android OS is going to crash your app. So that's something you want to avoid. So I look at this other table below it, and it gives me different object types, how many are allocated, and the total size overall. So I'm going to look at these byte arrays. Now bitmaps are represented by byte arrays. So I can see in my app, I have 10 megabytes worth of bitmaps being allocated. And now I can look at this bar graph below, and it gives me allocation count per size. So I can see I have 10 megabytes worth of bitmaps being allocated. And now I can look at this bar graph below, and it gives me allocation count per size. So I can see I have 10 megabytes worth of bitmaps being allocated. And now I can look at this bar graph below, and it gives me allocation count per size. So I can see I have around 3 allocations of objects around 152 kilobytes. And these larger ones, these around half meg, I got about 17 bitmaps at around half a meg in my app. So, this is nice. It gives me like an overall view of my heap and some objects, but this doesn't help me find any bugs, right? So that's why I need the allocation tracker. So it's pretty simple. You have your app selected and you click Start Tracking. Now this is the same as method profiling. I click Start Tracking and I need to perform some actions. I need to collect some data to be aggregated so I can look at it and analyze it. So I do some animations and I go back to DDMS. Now you might want to immediately click Stop Tracking. That's going to delete all the data you just collected. You got to click Get Allocations first. Now this gives me all the allocations, every object allocated on those few clicks, on those few animations. So I'm looking in here and I can sort by the order that the object was allocated in, overall size, where it's allocated at. So this is pretty nice. I can look in here, I see a bunch of 1 meg allocations. But this doesn't help me too much. I need to see object allocations compared to other object allocations. I need this data to be aggregated into some sort of graph so I can visually see how much space is taking relative to other allocations. So that's where Android Studio comes in. So to track object allocations in Android Studio, same concept. Start, perform some actions, and stop. So down here, after you drag it, you got to drag this Android monitor pane up first. And by default, log count will be selected, and you want to come over to this memory tab. So you want to click Start Record right here, Start Allocation Tracking. So I click that button, I go to my app, and perform some more animations. I got to collect some data. I go back to Android Studio and I click Stop Recording. Now again, I have some data pre-allocated for us to look at. So after you click Stop Recording, it's going to give you this view. And what you want to do is you want to click on this little pie chart to get this sunburst view. Now this is what we're going to look at. A nice data visualization of all of my object allocations. So this chart, it's pretty awesome. It's nice looking. But how do I read it, right? How do I read this data? So in this top left-hand corner, these are the smallest allocations. And as it goes clockwise, I can see the allocations getting bigger and bigger and bigger. All right, so I'm looking here, and if I'm looking for the largest object allocations, you can start in this bottom left-hand corner. So these are the larger allocations and group of allocations. But what led to this object allocation? I'm looking here in this, I'm looking at these objects, right? These layout parameters objects right here. It's a group of 61 object allocations on this outer ring. And you can see the full stack trace on this right side. So each ring represents an additional method call. So this inner ring is the beginning. It represents everything in the app. And as I dig to the outer rings, I can see the stack trace start to fill out. I can see what led to this object allocation. So all these object allocations, these layout parameters, they're all allocated in my bug list adapter. So it gives me the method name of where this object was allocated. So this is what I want to eliminate. I don't really need all these objects being allocated during my animations, during my value animator. So let's fix the bug. So I open up my bug list adapter, I go down to the stack trace, the method where the stack trace told me, and I find my bug, right? So I see here I'm allocating layout parameters every time during my animation loop. Now this is very common to some new Android developers, and I can just recycle the existing layout parameters instead of initializing them every time. So I get my layout parameters, and then I set a property and I call request layout. This tells Android to refresh that view. So I fix my bug, and let's redeploy my app and go through memory allocation again, collect some more data. So add some developers to my sprint, do some animation. All right, so it doesn't appear to be lagging, but let's just do some allocation tracking just to make sure. I expand this Android monitor pane, click on memory, start recording a new session. Collect some data, and then stop recording. And it'll give you another data set to look at. So here's the pie chart after the bug is fixed. So now I want to look for large object allocations, something I might be able to fix that might cause a lower end device to crash when using my app. So I'm looking and looking, and I can't really find anything with my app's namespace. This is all native Android stuff. So this is what you want. You don't want any of these large outer rings to be allocations that your app is using. So this is great. I eliminated unnecessary object allocations. All right, so I used some profiling tools. I found some bugs and did some measurement of before and after, how much time was saved, how much milliseconds were saved. But how do I fix these bugs? So here are some best practices. Generally, garbage collection on Android is not that great. So there's a couple design patterns you can follow. The recycling or object pulling pattern, specifically when you're dealing with scrolling, animation, or game loops. Now this means there's code being executed very fast, 60 frames per second for game loop, and I don't want to allocate objects during that time. So it's really going to slow down Android because garbage collection has to kind of like speed up and clean those object allocations. You can also avoid unnecessary object allocations, just some general caching. I don't need to load bitmaps every time. I can maintain a static cache of them or other resources. There's even some optimized data containers, specifically that are in the Android SDK. Instead of using a hash map, I can use a sparse array or a sparse in array that Google has provided that are optimized for Android. Some general primitive data types. You want to avoid using floats. They're about 2 times slower than integers. They just take up too much space. You want to utilize static and final keywords as much as possible. Static's around 15 to 20% faster. And you're a Java developer and you're used to using getters and setters to access your object properties. But you kind of want to avoid this on Android, right? Direct field access, just making your property public, is 3 times faster than that extra method call of your getter or setter. Now we covered some just pure Java best practices on Android, but what about my layouts? What's something I can do to improve performance there? So with Android 5.0 came the recycler view. This replaces list view and grid view. And it even has a couple methods I can call to further optimize my recycler view. For instance, if I have 50 items and I'm not adding or removing items, I can call setHasFixedSize, pass in 50, so it can internally do some further optimizations. And what if I am changing my data set? What if I'm updating a name or a description and I need to notify the recycler view to update the view? So I can do that using notify dataset change, but this refreshes all the data, everything in my list, not just that one element I updated. So these other methods, notify item changed, that's something I want to call to only refresh that one view I updated. And if I'm adding new objects or removing new objects, I can call notify item inserted and notify item removed, instead of just calling notify dataset change every time I change my recycler views data. So I have some views that I can reuse in different layouts. So instead of injecting a fragment every time, I can just use this include tag, and I can include other views into my other layouts. And then so I have my recycler view, and in the onCreate view method, I need to inflate a view, right? I want to inflate a layout and pass it into my recycler view. So by default, you usually have a view group at the top level in my XML file. Now, you don't always need this. I can set a merge tag as the root tag and avoid that extra view group if it's not necessary. And this is even something I learned recently. So a common instance on Android apps is an image on the left and some text on the right. So usually you're going to use a linear layout or a relative layout to hold these two different views. Now I can avoid this using compound drawables, where I can directly set a bitmap to the text view and avoid those other extra views to really improve performance. So I touched base on some asynchronous previously. One of my bugs was I was loading images on the main UI thread. So this is why I need to use asynchronous programming. The main UI thread is for the UI, only the UI, to lay out new views, to refresh the views. I want to avoid doing things like loading images or hitting a web service, because it's really going to cause the UI thread to lag and even crash my app in some instances. So like I said, what should be asynchronous? What should I execute on a background thread? Network access, image loading, just general like image resizing, other bitmap manipulations, and general file access if I need to save something or load a large file. So how do I use asynchronous programming? So to set up my async task, there's a method called onPreExecute. Now this is executed on the UI thread. This is where I'm going to set up some properties. Then after that, do in background. Do in background does the heavy lifting on a background thread. This is where I'm actually going to put the code to hit a web service, to download some data, to load a bitmap from disk. Anything heavy process intensive that might lock the UI thread. And then when I'm finished, so say I was loading an image from a web service, now I need to update my image view. Right? I need to communicate with the UI thread because my async task is finished. On post execute. Executed on the UI thread, and this is where I want to call imageview.setImage source. So what if I have a really intense background process? What if I need to notify the user of some progress, like a progress bar or how much data is being downloaded? I can do this using onProgressUpdate. Now this is executed on the UI thread to notify the user of the UI changes. All right, to summarize what we covered today, what are performance and profiling tools and why do I need them? What tools are available on Android, specifically using DDMS, and what's new in Android Studio? And then we went through a profiling sample of method profiling and investigating the heap space and some memory allocations using DDMS And then we use the new memory allocation tracker in Android Studio. And then we went over some best practices, just general Java programming, general layout management, and some asynchronous programming on Android. So if you want to keep up to date on the latest and greatest on Android development, you definitely got to read the Android SDK. Right? That's where the best stuff is. You want to follow the official Android blog to receive updates in Android Studio and the new performance tools that they're releasing. And follow the GrapeCity Xuni blog. I'm going to be writing a blog on MVC versus MVP architecture on Android later this month. All right, questions?
So we did have a question earlier just about what sort of profiling tools would be coming with Android Studio 2.0. Chris, do you have any insight into that?
Yeah, so Android 2.0 it's mainly focused on just development enhancements. How can I write it out faster? And they have some fast deployment to my emulator, and they have a new emulator. But profiling specifically, they've only released a new GPU profiler. If you need the profile, your OpenGL code. But that's about it for Android 2.0. I'm sure they got some future enhancements.
We did have another question here about how many languages the DDMS monitor supports. Now, it's part of the Android SDK, so it's all Java-based as far as code goes. As far as localization goes, it would have the same options as Android Studio, I'm assuming. Do you know offhand, Chris? I think like localization.
Yeah, I mean, absolutely.
What can we use for profiling of Cordova-based apps? So I know a little bit about doing hybrid app development. You can use these tools to some extent to do some profiling, of the overall performance of your application. The thing with Cordova or Ionic or any of those hybrid solutions, you're executing interpreted Java code basically inside some kind of web view that you're going to be running directly on the device. So as far as actually doing some kind of profiling of that interpreted JavaScript code, I mean, you're going to have to do that in some sort of browser outside. Basically, your JavaScript code, by the time it gets migrated into an Android Studio project or into Eclipse, at that point, all you're going to be able to do is draw very broad conclusions from the profiling tools in those IDEs. Really, you want to make sure that that code is as correct as possible, as high performing as possible before you even get to that point. That being said, if there's a big problem, you'll still be able to find out that there's at least a big problem in the IDE in Android Studio and those profiling tools or in Eclipse. Are there any other questions? Okay, well, I don't see any more questions coming in. Chris, thanks for joining us today. Everyone who's attended, thank you for being here. We would like to do more of these in the future, so if you guys have any further input on topics that you'd like to see, we'll be sending out an email after the fact. If you have any questions, feel free to go to gozuni.com and post your questions in the forums. But once again, thank you all for joining us, and have a good rest of your day.